Good morning, everybody. My name is Phil Bernardin. I'm with a company called Engage Agro. And what we're going to do, along with Brian Barris, we're going to cover on plant growth regulators and lodging and that type of thing during this section. So we'll start here.
Come on in closer.
Where we had the PGRs applied, and then we'll go off to Brian's plots afterward in the winter wheat. What we're looking at here, just to start, we got wheat going this way. Then we got barley, and then we got oats. And then sprayed across are the three different types of PGRs. So manipulator going this way, which is chlormequat chloride, and we'll touch on that. Then we have ethyl, which is ethafon. And then we have trinexapac ethyl, which is the actual active. It doesn't have a trade name yet. So those are the three PGRs going across the three crops through here. And so we'll touch on what a plant growth regulator is and what the difference between these three products are and what the similarities are. So that's why the reason I handed these out. Everyone have one of these? We're just going to follow along here. There's a few key points I want to touch on when relating to plant growth regulators. So starting on page 1, I guess. Yeah, 1. So what are plant growth regulators? To be a PGR, you have to be classified a PGR, you're going to alter the hormones in the plant. So anything that alters the hormones, whether that's increasing them, decreasing them, eliminating them, whatever you're doing, if you do that within the plant, you are considered a plant growth regulator. Now, when we're talking cereals here like we are today, what we're really specifically looking for are more like a plant growth retardant. So something that's going to shorten the crop, help prevent lodging. But PGRs are used extensively in horticulture. They use PGRs for all kinds of different things in horticulture in terms of thinning apples early in the season so that you have less apples but they can get bigger. They then use a different PGR later in the season to hold those apples on the tree so they don't fall before the guys can get out and pick them. So there's a lot of different things and a lot of different ways we can change plants using hormones. Not quite as prevalent in terms of all the uses in terms of cereals, but it's worldwide. It is the biggest use of plant growth regulators would be their use in cereal production to reduce lodging. So if we're talking altering hormones, what are hormones? Hormones, kind of the high overview look, would be a way for the plant to communicate with itself. So, for instance, if I plant my wheat seed in the spring, how do the roots know to go down? And how does the coleoptile know to go up? That's controlled by hormones. In that case, it's controlled by auxin. And so that's one example of what a hormone will do. Another example, so we can maybe turn to page 2. And at the very top there's 5 kind of primary hormones. There's more than 5, but these are the 5 that are the best understood in terms of what they do within the plant. So you have your auxins, like I just touched on. Auxins play a big role in cell elongation. So again, I just touched on how does that coleoptile know to grow up. The way it grows up, right, the way any plant will twist is the cells on the one side will grow longer than the cells on the other side, and that's how that plant will twist up. And that's controlled by auxins. Cytokinins play a big role in cell division, so again, helping with growth, but instead of making the cell bigger, they primarily help the cells divide. Gibberellins play a big role in cell elongation and cell division. Again, primarily cell elongation, but a little bit with division, and we'll touch on gibberellins a little later. Abscisic acid, another good example of how the plant will communicate with itself. So this year, we're into quite a dry land scenario where we're not getting a lot of moisture. The plant, if it's sensing, the roots are sensing they're not getting any more moisture, they'll increase abscisic acid production. And then that abscisic acid will travel from the roots up into the leaves, and then it'll trigger the stomata to close. And what happens when I close my stomata? I prevent water loss or transpiration. And so when I do that, I'm trying to keep the moisture I have so the plant doesn't just dry out and wilt and die. So that's another example of a hormone working with the plant, trying to save it in a drought kind of condition. Because it's closing the stomata, you can see there it's in the red section with inhibiting plant growth. If I close the stomata, what else am I doing? I'm preventing carbon dioxide from entering the plant, which is problematic for photosynthesis, right? So abscisic acid production will increase and the plant will stop growing, but it's actually trying to save itself. And then the last one is ethylene. So ethylene plays a couple different roles in the plant. It helps with senescence at the end of the year, and it kind of helps the plant convert into that going into harvest scenario. It also helps, and we'll touch on that, helps with stunting the growth of the plant as well. So that's a quick look at ethylene. So now we have a base kind of understanding of the hormones. The two I really want to focus on are gibberellins and ethylene. Mentioned that gibberellins play a big role in getting that crop to grow, specifically the cells to grow, and it really helps with stem elongation. That's when gibberellin plays a big role in the plant. The other one is going to be ethylene, and then that's the one that's going to help with senescence, but also helps with the stunting of the growth. So we'll touch on ethylene first. And ethylene is how ethyl works. So that's the middle one here. So when you apply ethyl to the plant, you are physically adding ethylene to that plant. So you're adding additional ethylene. When applied at the right time, that ethylene will help with the stunting of the stem and will thicken it, which is what we're looking for when we're looking to reduce lodging. What's the concern with adding ethylene to the plant? If I have a plant under stress, what's that plant under stress going to create? Say if I get a hailstorm come through, that plant will naturally produce ethylene. That's kind of one of its defense mechanisms, is to increase ethylene, because now it realizes that it's got some issues. It may not make it to maturity unless it gets to maturity really fast, and so it'll increase ethylene production to try to speed up maturity. So if you add ethyl to a plant that's stressed, you're adding ethylene to a plant that already has ethylene. And so you're actually kind of adding additional ethylene, and what's going to happen is you may end up with a bit of crop damage. So ethyl works really, really well, but the plant really needs to be stress-free, and the application timing is relatively narrow. So the ideal timing is going to be flag leaf. I don't have a ton of experience with ethyl, but I was talking to a couple of agronomists yesterday, and they said when they recommend ethyl, they want the main stem to be full flag and the boot is starting to fill. And that means typically that your tiller will be at full flag, because they don't want anything going on before full flag, because it will harm the crop. So if you go a little earlier on the main stem, you might end up hurting your tiller, is what they were saying. And then as soon as that boot breaks and you start seeing awns, you're basically done. Because if you get any ethylene into that head, it's going to cause some damage there as well. So it's got a bit of a tighter window, but applied properly, ethyl works really, really well. So that's the story on ethyl. Now the other two products, so manipulator, which is chlormequat chloride, and trinexapac ethyl, are both anti-gibberellins. So they both work by reducing the amount of gibberellin hormone in the plant. So that gibberellin really starts getting produced at stem elongation. So the plant's going to go ahead and start producing its leaves, and it's going to start producing its tillers. Once it's done tillering is when it's going to convert into stem elongation. So that's when it's going to start pushing that stem up, and that little head's going to start going up the stem. And that's when the gibberellins are really going to get produced. So that's going to be the ideal timing for an anti-gibberellin product. A couple differences between trinexapac and chlormequat. So despite the fact that they're both anti-gibberellins, chlormequat chloride is slower to work. So when you apply it, it works. It doesn't start working right away. It slowly starts working, but it'll last a relatively long time, and it has a good residual. Trinexapac is almost kind of the reverse of that. As soon as you apply trinexapac, it starts working right away, but it works for a very short period of time. And that does become important because timing is a little bit different between the two products. So with chlormequat chloride, we can go on a little bit earlier. So it's not ideal, but you could go on, say, at herbicide timing. And we've done that kind of work, put it in with your herbicide, and you will see some results. What you're doing, though, is you're putting on your anti-gibberellin at that 3 to 4 leaf stage, and there's really no gibberellins there yet. So it's got nothing to do. But I put it on, it's got enough of a residual that there's going to be some active left at that stem elongation stage, which is usually about the 6 leaf stage. And then at that time it'll start working. But of course, because I put it on here, I've lost some. It's like going on at a light rate at that timing. But it does work. And then we can go as late as flag leaf as well to get our results in there. Trinexapac, because it doesn't have the residual that chlormequat does, it needs to go on closer to that true 6 leaf stage, and we'll look at staging here in a second. But it needs to be, you can't put it on early because it'll just try to work right away. There's nothing for it to do, and then it dissipates and there's nothing left. So the window with Trinexapac is going to be a little bit tighter than the window with Chlormequat, and that's just a function of how those actives work within the plant. Having said that, because Trinexapac works right away, it's a bit more effective. So it's going to work a little stronger right away and be more impactful right away. Whereas because the Chlormequat takes longer for its effects to come through, it's not going to be as dramatic to the plant in terms of that shortening effect. So they're very complementary. Like typically in the UK, where both products are available, they'll tank mix them and use them together because of the way they work. One is slow acting but with long residual. The other one works right away with no residual. So they're very complementary that way. In terms of timing, touched on it here a couple times, but the ideal timing, according to the BBCH scale, when that stem starts to elongate is going to be what's classified as growth stage 30 or 31, up to growth stage 32. And the way you look at growth stage 30 is if you take your plant and you split it up, you split down the middle of the stem, if that little head is about a ½ inch above ground, that is considered growth stage 30. Growth stage 31 is when your first node is about a ½ inch above ground. And then growth stage 32 is when your second node is a ½ inch above ground. So that's how you classify growth stage 30, 31, 32. And that's the optimal window for any anti-gibberellin, whether it's Chlormequat or Trinexapac. That is your ideal window for application, somewhere in there. Obviously that's not the way we typically talk about crops. It coincides quite closely to the 5 to 6 leaf stage. Typically, if you're into the 6 leaf stage, you're going to be right close to that timing. And then if you really want to double check, you can go ahead and take a look at it from that perspective. Any questions on that so far?
How's crop safety with manipulator versus ethylene? Like, if say manipulator you are at a staging, are you just going to see a loss in results, or is you going to have yield effects?
So the question is crop safety with Chlormequat chloride versus the ethylene. It is safer. It is safer with Chlormequat chloride. The worst case we've seen over the last 4 years in our trials is loss of efficacy. So if you go really too early or a little too late, it has nothing to do and it has no effect. And in really dry conditions, last year up in the Peace where they only had like 1.5 inches, 2 inches of rain, we applied some. The crop never got more than 18 inches, treated or untreated. Well, it had nothing to do. So with Chlormequat, worst case scenario is going to be loss of efficacy, whereas with the Ethifon, like we mentioned, you really need to make sure you get it on at the right time. Having said that, I wouldn't go past flag leaf with Chlormequat. It's not something we've ever looked at, mostly because we know it wouldn't be effective, but I don't know what would happen if you sprayed it right on the head. I assume it wouldn't be great.
In your guys' trials, are you just applying manipulator and ethylene by itself, or are you tank mixing with any fungicides?
So the question was tank mixing with, I don't have a lot of experience with ethyl, so I'll kind of leave that, but with Chlormequat manipulator, when we were doing our trials, we did do some compatibility work and looked at tank mixing with herbicides and with fungicides and haven't seen any issues. Having said that, we've never done more than like a grass, a broadleaf, and the PGR in terms of the herbicide timing, and then just the fungicide and the PGR and the fungicide trials. We were told by the manufacturer of the UK not to mix it with nitrogen, so we didn't, so we don't know, but they've said that that's not a good idea. If you guys want, I went and, where am I here? I pulled some plants this morning and kind of tried to find some different stages here. They're kind of dried up a little bit, but certainly this is just a demo plot, so we're welcome to walk in here and cause damage. They brought some shovels out. I got some knives here as well if you guys want to come out and try to pull a plant and try to kind of see where we're at stage-wise. This plot was sprayed on Thursday, which would have been right at the start of the ideal window, so they staged it pretty good. So for those of you who think Ken's not that intelligent, he can do some things apparently. So the only thing is though, the ethyl was sprayed on that day as well, which I would have considered that to be a little early. So they went and did them all three at the same time, and they did it ideally for the anti-gibberellin products, but probably a little early for the ethyl. Under irrigation they may get away with it, but in dryland conditions I probably would try to hit that timing as close as possible. So what I got here, I realize this isn't ideal, but I've got some, where the little head is about a ½ inch above ground. So we're looking here, most of these are going to be growth stage 30. One of them had a node out, but I think I kind of dried up. But anyway, so 30, 31 is roughly where we're at. If you guys want to kind of wander in, take a look quickly and see what we have here in terms of timing so you get a little bit familiar with it. Yeah, so what we're looking at here, so this would be your plant. I've got the seed there, so this would have been underground, and that's the little head. It's kind of shriveled up now, but so it's about a ½ inch above ground, so that would be growth stage 30. Yeah, there's knives here if you want.
Yeah. So what are we cutting away?
30 feet. Looks like everything shriveled up. So let's take. We'll pull everything off. So we'll take our main stem here. It's about the 6th leaf stage. The other thing you can do too is if you squeeze down the plant, the stem is hollow, right? Mm-hmm. But if the head's starting to move up, then it's going to start feeling it in there. So you can feel it. It's right around there.
Right around there.
Yeah. So we, just by doing that, we know this is we're right in that perfect timing. Now, I've determined there's a reason I'm not a surgeon when I do this, but. Yeah, I kind of split it right in two, but there you can see that little head, right there, right? And so, and then that little first node is right there. So this would be growth stage 30. Yeah, this would be growth stage 30, which would be the beginning of your window to apply.
Growth stage 30 is ½ inch above.
The head is a ½ inch above the ground. Yeah, and then 31
first node
is the first node. Yeah, if we pick a bigger plant, that would be 31, and that first node is a ½ inch above ground.
What is the node again?
The node, the node is that, this would be the node right here in this case, but the head hasn't really elongated above it yet. But what happens when you get to 31 is the head's going to be pushed up about a ½ inch, and then the node will be about a ½ inch below it, but a ½ inch above ground. Yeah, we'll see if we got a bigger plant. And then when the second node gets to be about a ½ inch above ground, then you're, so this one's got a node, so this one's bigger. So you got your node here. Can you see it? You can kind of see it. And it's starting to come up. So this one would be more like growth stage 31. Let's see if I can do this without killing somebody. So here, oops, sorry.
I have trouble deciphering the main stem from
The tillers?
Yeah. This guy the main stem?
Yeah, typically your main
Just
stem will be the longest one, right? And then
I guess looking at the top instead of looking at the bottom.
Yeah, and then usually the tillers are going to be coming off the side.
Yeah.
And then the way you stage the leaves, right? You'd be the one.
Yeah.
If you have 1 or 2 tillers, they're your first 2 leaves, and you count the leaves going up. So we're looking for roughly the 6th leaf stage.
1 or 2 tillers are the first 2 leaves.
Yeah. The leaves that they grow out of it would be your first 2 leaves, but you don't count the leaves on the tillers.
Okay, good. Yeah, okay, yeah. So this has no node yet.
No, so that would be more until
Until
30. Stage 30. But this one here, I kind of massacred it now, but here's where that node was. So this would be more early 31, kind of getting into that 31 staging, yeah.
Okay. Do you see an increase in nutrient uptake too by adding like a manipulator to it? Like, will those plants want to drive more nutrients into it?
Well, what we're seeing is in the absence of lodging, we're still seeing a yield response. And we're attributing that to the fact, like if you shorten the crop by 4 to 6 inches, now you've put less energy into that vegetative growth, and you've got more for the grain production.
So you don't need to increase your nutrient packaging.
No, well, what we're seeing is even, guys in our trials, because we had smaller trials, they were kind of keeping their standard practice and still seeing a yield bump. Now I think the reason they would use PGRs in other areas would be really to push it even more, and I think that's where we're going to go with it with time as guys get more comfortable is, well, okay, I can do it at this rate, but can I push my fertility package a bit more and get even more of a yield bump? And
because like with the Ethro, what I have seen anyways is using natural to shorten that plant, you're able to go with a higher nitrogen. You can really whack on the nitrogen like they do in Europe and do multiple timings of it. That way you're getting more nitrogen into your wheat.
Yeah, and that's what we've got trials back there with Fairbanks Murder. And what we're doing is we're doing fertility at 100%, so kind of like a standard grower or whatever the soil test said, 125 and 150. And we've done that for the last few years, and typically the 125 pans out. Like you get enough of a yield response out of it to more than offset the cost of fertility. So I think that's probably where we'll go going forward.